Hey, good morning. I'm going to be talking about subtracting fractions today. We're going to just do a little quick review. I know I did one the other day, Friday, for you, but I just want to do a quick review again because repetition is the mother of learning and it's not going to hurt us. So if we're looking at this fraction here, we have 5/8. What it represents is that it's not a whole number. Fractions are always part of a number. They may have a whole number attached to them. We talked about that. It's called a mixed number. But in all reality, the fraction part is the section that has the number on top of a line that has another number underneath of it. It's representing a part. So in this fraction, 5/8, we have 5 out of 8 of something, right? So let's talk about muffins. Muffins maybe come in a pack of 8, and as soon as they get home, you and your siblings will have one. There are 5 left over. So there are 5/8 of the package left over. Then what we're looking at here are two different numbers, two different things that represent two different things. So the top number, 5, that's called the numerator. And that tells you how many pieces there are. Pieces, right? And then 8 tells you how many there were to begin with, or the size of the package, or the size of the pie, or the size of each piece. And so that's called the denominator. The denominator. And the denominator, like I said, represents how many there were to begin with or the size of each piece. If the whole was cut into eighths, then that's what the denominator is, eighths. And that tells you the total of pieces that there are, right? Okay. So what you should have learned in third, definitely fourth grade, is how to subtract fractions that have the same denominators. And this is a pretty easy process. There's not a lot to remember for it. Just take your time, kind of cement it into your brain. But if we're going to go back and we're going to look, and the next day there are 5 muffins left and 3 more are eaten. So we have 3 of those 8 are eaten or consumed for breakfast, right? This is actually a pretty easy process. If both the denominators are already the same, you just slide it over. And so our denominator is going to stay eighths. If they're different, that's when you have some work to do, and I'm going to show you that today. But then you go up to the top and you just simply subtract 5 minus 3. What is 5 minus 3? It's 2. So 2/8 would be what's left in the box of muffins. You can simplify that, and I'll talk about that a little bit later, but that would be a fine answer for me right now, 2/8. You'll notice at the top that it says 1 out of 6 slides. It's a fraction, right? There are 6 slides for this, and then there'll be 2 pages for you to do independently. All right, so let's look here. We have some fraction tiles. I'm going to be using the same website I was before, the fraction strips from toytheater.com. I will post that link in the lesson's description today, and you can use that. Absolutely feel free to use that. So I already have it set up for the first problem that we have, and I'm going to go step by step, and I'm going to bounce back and forth between each website. So here it says solve 2/3 minus 1/6. Find fraction strips all with the same denominator that fit exactly under the difference 2/3 minus 3/6. 2/3 minus 1/6. And you can see that they started with 6. And I'm going to go back to our fraction strips and show you that. I have 2/3, 1, 2, up there. I left the pink hole up there so you could see that it is actually less than 1. And then we're going to be subtracting 1/6. Now what I'm going to do is in that 4th line, I can't just add them there. So we're going to go 1, 2, 3, and they perfectly line up. So I added 3/6 to the number, and you can see that's what they did here. They have the 3/6 right here. So 2/3 minus 1/6 is 3/6. Good. So now let's go back to that fraction set and see what else we can use, because 1/6 tiles are not the only tiles that will fit in there. So I'm going to go back here. I'm going to clear my sixths out. I'm going to leave that 1/6 there because that's what we're subtracting. And I'm actually going to bounce over to my thirds. So can I fit thirds in there? I can fit one, but I can't fit another. One is too little. Two is too many. So thirds won't work. So I'm going to get rid of those. I can go to fourths. One fits and two fits. So how many fourths did I use? There are 2 1/4 tiles there. So 2 fourths. So I'm going to come back here and I'm going to write that in. 2 fourths. Okay. Then it says find another fraction strip with all the same denominator that fit exactly under the difference. Draw and use the fraction strips you used. Oh, you can't draw because we're online. But I'm going to get rid of the fourths, and now I'm going to bounce to fifths. 1 fits, 2 fits, but 3 doesn't. 2 is too small, 3 fifths is too big, so that won't work. So I'm going to get rid of it. We already used the 6 tiles, and we said 3/6 would fit in there. I'm going to use the 8 tiles. 1, 2, 3, 4. 4 fit in there perfectly. So I'm going to go back to the sheet and I'm going to write, oh, I got to count them. 1, 2, 3, 4. 4 eighths. 4 eighths also fits in the difference area. Now I'm going to go back and I'm going to put the other ones right here because I want you to see something. There's actually more. So I'm going to go back here. We did eighths. And now I'm going to slide all these back and I can do tenths. 1, 2, 3, 4, 5. 5 tenths fits there perfectly. So let's put that here. 5 tenths. Okay. Let's go back to those fraction strips, get rid of these ones. And I'm going to use twelfths. 1, 2, 3, 4, 5, 6. 6 twelfths also works. I'll put that here. Now look at all of the fractions that we had. 3/6, 2 fourths, 4 eighths, 5 tenths, and 6 twelfths. While each answer appears different, all of the answers can be simplified. That means we're going to just change the fraction to represent the same amount, but it's going to look like a smaller number. It's just representing what it actually is. So just look at that for a minute. 3 is what of 6? Half. 2 is what of 4? Half. 4 is what of 8? Half. 5 is half of 10, and 6 is half of 12. So we can rewrite it as 1/2. 3/6, 2 fourths, 4 eighths, 5 tenths, and 6 twelfths are all a half. It's just that the sizes of the pieces are different. And as a general rule, the bigger the denominator, the smaller the pieces. Think about it. Would you want something cut into the size of twelfths where each piece is just really little, or something cut into the size of fourths? Think about a pizza. Would you want 1/12 of a pizza or 1/4 of a pizza? Definitely going to get more if you get 1/4 of a pizza. But after looking at all of them, they all equal 1/2. Hopefully you kept up. Again, if you have any questions, I'm pretty much available every day, Monday, Tuesday, Wednesday, Thursday, Friday, from 11 until 1. And then on Fridays, we have our Google Meets. All right, let's look at these. Use fraction strips to find the difference. Write your answer in simplest form. Simplest form is when you make that number into the smallest fraction you can. And I'll show you that, okay? So we have 7 tenths minus 2 fifths. Let me get that set up here. 7 tenths. 1, 2, 3, 4, 5, 6, 7. And I just need to double check. 2 fifths. 1, 2. Now, how much extra space is here? We're trying to find the difference. So I can see that 1/2, too big. 1/3, it's really hard to see, but it's too big. I guess it's not too hard to see, but you got to be careful. They're close, but it's not the same size. What about a 1/4? Too small. We could put another 1/5 in, but we wouldn't be able to put a second 1/5 in, so I'll get rid of those. How about 6? 1, 2. Look at that. It's close, but it doesn't fit. Okay, what about tenths? Or I'm sorry, not tenths. These are eighths. Eighths, again, close, but it's too big. Excuse me. Tenths we can fit in, and 3 fit in perfectly. Okay, 3 absolutely fit in perfectly. So I'm going to go back to my sheet, and I'm going to write 3 tenths. And I'm going to go back and I'm going to double check 12ths. But 12ths won't work either. So our answer is 3/10. Now, I want to show you on here, I could have done this without using the fraction tiles, okay? So if I look at 7/10 and 2/5, if I look at the denominators, I think about their multiples and what do they have in common? They both have 10 in common. So 7/10 can stay the same, but I need to change 2/5 so that it has a denominator of tenths. And let me show you how I would do that. I would do 2/5. This is all for 2/5. 2/5 equals how many tenths? So now here, what I do is I look at that 5 and I go, how can I go from 5 to 10? And the answer is you multiply it by 2. So I'm going to do the exact same thing up here. 2 times 2 is 4. And now we have 4/10. And if you look here, that's what I had, right? 4/10. I'm subtracting 4/10, which was the same as there, okay? Now, 3/10 is already in its simplest form. I wouldn't be able to divide both of them by the same number. We're good. Let's look at number 2. 2/3 minus 1/4. Let me go back to my fraction strips, clear this out. 2/3 minus 1/4. 2/3 minus 1/4. How much space is left? Well, let's start. Half is too big. Thirds don't fit. Fourths don't fit. Fifths are so close, but they are not exact, so don't use them. Sixth. Sixths don't fit. Eighths. Nope, eighths don't fit. Tenths. Ooh, that's really, really close too, but it's not exact. You can see that it does not exactly line up, which leaves my 12ths, and the 12ths will they do it? Yes, they fit in exactly. So there are 1, 2, 3, 4, 5 12ths there. Now I'm going to go back here, and I'm going to write in 5 12ths. Okay. Now, again, I'm going to look at these denominators and think to myself, what multiple do they have in common? Count by threes. 3, 6, 9, 12, 15. Count by fours. 4, 8, 12, 16, 20, right? I heard the number 12 in both of those. And look where that popped up. Now, in order to change them, you just have to make sure that you're multiplying by the same number. So for example, how do you get from 3 to 12? The answer is you multiply by 4. Do the exact same thing to the numerator. 4 times 2 is 8, right? So now we do the second number, 1/4. How do you go from 4 to 12? You multiply by 3. Do the exact same thing to the top, and 1 times 3 is 3. Now, just like we were talking about on the very first slide, you can subtract 8 minus 3 because the denominators are the same. 8 minus 3 is 5, which, ta-da, was our answer. Okay, now simplest form, both of these ended up in simplest form, so I guess I'm a little confused as to why they gave that direction. But let me give you an example right quick of what it would mean if you needed to change it to simplest form. If the answer for some reason were to be, I'll write it in green since it's just new side information. If one of our answers would have been 4/12, knowing your multiples is going to be really helpful for this one because we can make this a more simple fraction. And we can do that by dividing both of these numbers by the same number. What can 4 and 12 both be divided by? They can both be divided by 4. So 4 divided by 4 is 1, and 12 divided by 4 is 3. So 4/12 is equal to 1/3. That's what simplifying means. And I think it pops up a little bit later. I'll go over it again. All right, let's go on to the next slide. Here we have some fraction tiles and problems. I'm going to walk through them. I know for some of you this is clicking really fast, but I want to make sure that everybody has a fair chance. So I'm giving everybody a fair chance. So number 3 says we have 5/6 minus 1/4. 5/6, 1, 2, 3, 4, 5. 5/6 minus 1/4. Now, before I try all of them, what I'm going to do is I'm going to think about 6 and 4. How are they alike? How are they different? Can any of these numbers work with both of them? And just like I said before with the 4/12, we could divide both of them by 4. Look here and think about the multiples of 6 and 4. 6, 12, 18, 6, 12, 18, 24. Lost my thought for a minute. And then 4 would be 4, 8, 12, 16. Did you hear that? 12. And guess what we have tiles of? We have tiles of 12. So I'm going to squeeze these in. I have 4, 5, 6, 7. I have 7/12. See how fast I was able to get to that answer because I know my multiples? If you're taking a shower, just count by 5s, count by 10s, right? That you've been doing since kindergarten. Count by 8s, count by 4s, count by 6s, just to get those numbers familiar in your head and keep them familiar in your head. So my answer here is 7/12. So I'm going to go back here and I'm going to write in 7/12. Okay, now I can double check that. I can turn them both into 12s. How do you go from 6 to 12? You multiply by 2. So do the same thing to 5. 5 times 2 is 10. How do you go from 4 to 12? You multiply by 3. So we do the same thing to the numerator. 1 times 3 is 3. 10 minus 3 is 7. So we're good. Okay. Number 4 says 1/2 minus 3/10. Let me get rid of all of these. 1/2 minus 3/10. 1, 2, 3. Again, think about what numbers 2 and 10 might have in common. I can see 1/2 is going to be too big. 3 is not in common. 4 is not in common. 5 is, though. But when I count by 10s, Miss Witkowski, I don't get 5. No, but you can divide 10 and get 5, right? 10 divided by 2 is 5. So that also works, fifths. But you can keep going. Sixths won't work. Eighths won't work. Tenths will. Now, this is the one that you could use here. And, excuse me, I added 2/10. So our answer is 2/10. And I'm going to do the same thing I did for number 3. 3/10 is already in tenths, so I don't have to change it. But how do I go from 2 to 10? Multiply by 5, right? 1 times 5 is 5, and 5 minus 3 is 2. So our answer is correct. Now, 2/10, this answer is not in simplest form. What can I divide both 2 and 10 by? If you were listening just a second ago when I was on the other website, I said it. You can divide both of these by 2. What is 2 divided by 2? Hopefully you said 1. And what is 10 divided by 2? It is fifth. This is simplest form. 2/10 is 1/5. And let me show you that. I'm going to show you the best I can. Well, it's already a terrible circle. Here is a pie, okay? And then you can see there are 5 pieces to it. I'm going to shade in one of those pieces to represent 1/5. Now, if Meyer was all out of pies, but I needed to bring some pies and I needed everybody to have one and there were 10 people, all I would have to do is split all of these pieces into 2 as equally as I could. And now, instead of having 5 pieces, I have 10 pieces. And how many of those pieces are blue? 2. So 2/10 and 1/5 are the same number, just represented in different ways. Okay, let's look at number 5. 3/8 minus 1/4. 3/8, 1, 2, 3. 3/8 minus 1/4. We don't have a lot of space left, and right off the bat, I can see which one it's going to be. What amount is left over there? It's 1/8. Okay, so 3/8 minus 1/4 is 1/8. And again, I can do the same thing. 3/8 is already in eighths, so I don't have to change it. But 1/4 is not. How do I go from 4 to 8 though? Times 2. Now the same thing needs to be done to the numerator. 1 times 2 is 2, and 3 minus 2 is 1, and the denominators just slide over, so it's 8, 1/8, and that was our number. Okay, good job. I'm going to move myself up here, and we'll do this last one. Number 6 says 2/3 minus 1/2. 2/3 minus 1/2. 1, 2 minus 1/2. Okay, now think about it. What number do 3 and 2 have in common? 3, 6, 9, 12, 2, 4, 6, 8. I hear 6, and look how perfectly that fits in. So the answer is 1/6. 1/6. Now, again, I'm going to do the same thing I did before. I want to change these both to sixths because I always want to check my work. So how do you go from 3 to 6? You multiply by 2. So you do the same thing for the numerator. 2 times 2 is 4. For 1/2, how do you go from 2 to 6? You multiply by 3. So do the same thing for the numerator. 1 times 3 is 3, and then 4 minus 3 is 1, which gives us 1/6. Okay, 1/6, 1/8, 7/12 we're already in simplest form. 2/10 we're not. We could divide both of them by 2. On to our next page. Now, we're going to use no more fraction strips. You can use them when you do your practice. Use them if you want to. But I'm going to do these last 3 problems like this, without using them. So number 7 says 3/5 minus 3/10. Denominators are not the same, so I need to figure out what is the common multiple between 5 and 10. And that one should be pretty easy. If you count by 5s, you get to 10 on the second one, 5, 10. So I'm going to slide 3/10 down because it's already in tenths. And now I'm going to change 3/5 to tenths, and I'm going to do that by multiplying. So how do I go from 5 to 10? Multiply by 2. So do the same thing to the numerator. 3 times 2 is 6. And now we can subtract 6 minus 3 because they're both in tenths form. And 6 minus 3 is 3. And our denominator is 10. 3/10 is in simplest form. Let's look at twelfths. 5/12 minus 1/3. If you count by 3s, 3, 6, 9, 12, you get to 12. So we don't need to change 5/12. We're going to keep that the same. 5/12 minus, now we're going to change the 1/3 to a fraction that has 12ths as a denominator. So how do you go from 3 to 12? 3 times blank equals 12. It's times 4. So 3 times 4 is 12. We're going to do the same thing to the 1. 1 times 4 is 4. And now we can subtract 5 minus 4 is 1. And our denominator slide over, so our answer is 1/12. Now, for number 9, I'm going to have to count by both of these because if I count by 5s, I don't get to 2. And if I count by 2s, I don't get to 5. So I have to find the common multiple. And I'm going to start with 2s because it's smaller, and I like to start with the smaller one. 2, 4, 6, 8, 10, 12, 14. I'm going to count by 5s. 5, 10, 15, 20, 25, 30. Now I noticed when I was saying them that I heard 10 both times. If saying them you can't hear yourself say the same number twice, write them down. Totally fine. We could go 2, 4, 6, 8, 10, and then 5, 10, and I wouldn't even have to go any further because I see 10s right there. Okay? Do what's easiest for you. I just want you to be successful. Okay? So how do I go from 5 to 10? 5 to 10, I have to multiply by 2. Now I have to do the same thing to the 3. 3 times 2 is 6. Then I ask myself, how do I go from 2 to 10? And the answer is multiply by 5. So I have to do the same thing to the numerator of 1. 1 times 5 is 5. And now I can subtract 6 minus 5 because both of these numbers are in the form of tenths. 6 minus 5 is 1. And our new denominator is tenths, and that is in simplest form. Okay, I have one problem left, and it's a story problem. And I just want to kind of run through this right quick with you. You do have 2 story problems on your work today, and I just want you to see it so you can also be successful. Number 12 says, the picture at the right shows how much pizza was left over from lunch. Jason eats 1/4 of the whole pizza for dinner. And I need to change this to here. Oh no, you can't see it. Whoops. Oh, this is a new platform for me, so I'm learning. Please forgive me. I'm just going to circle it like I had been doing. Okay, so let me start over again. The picture at the right shows how much pizza was left over from lunch. Jason eats 1/4 of the whole pizza for dinner. Write a fraction that represents the amount of pizza that is remaining after dinner. So we're going to take a step back, and I want to do all A, B, C, D, and E. And I want you to think about what this problem is asking you. And if you look, I circled it. What's the problem asking you? How much pizza did he have for dinner? I don't think you have to type any like this. Okay, so how much pizza did he have for dinner? Dinner is the key word right there, okay? I probably shouldn't have you circled that so big. Got it in the other space. Okay, dinner. B, how will you use the diagram to solve the problem? Here, what you can do is I'm going to make sure I'm still back on here. You can count the pieces. But you have to be careful because the denominator is going to change. So right now, we see that there were 8 pieces, but that denominator is changing to 1/4. C says, Jason eats 1/4 of the whole pizza. How many slices does he eat? Now, this is where you can go up to that picture of the pizza, and I'm going to use red, and we need to make sure that we're seeing it in fourths. And so an easy way to do that is to split it up and down in the middle and split it left and right in the middle. Now, how many pizzas are in each corner of that X, of that plus sign? Hopefully you see that there are 2 pieces there. Okay? D says redraw the diagram of pizza. Shade the section of pizza that are remaining after Jason eats the pizza. So let's say Jason eats these 2 in the top. How many slices of pizza are left over? 3. Okay, so we have to redraw it. I don't think you have any redraw ones. I'm going to go 1, 2 like that. That gives me 4 pieces of pizza. But that pizza was originally cut into 8 pieces, and now there are 3 left over. So I'm going to color in 3. Okay. Now it says there is blank of the remaining of the pizza remaining after dinner. What's left? We have to go back to 8s because that's what it was cut into, and there are 3 8s left. Okay. That's just an example of a story problem. You have 2 story problems I'd like you to try. If you have any problems, call me, beat me, text me, however you want to reach me. Okay? Good luck.